One more time. Had some technical difficulties trying to get this one coming up. 9.2-2D, example problem number 2. Another example. A stationary billiard ball, mass of 0.17 kilograms, is struck by an identical ball moving at 3.5 meters per second. After the collision, the second ball moves 45 degrees to the right of its original direction. The first ball moves 30 degrees to the left. What is the velocity of each ball after the collision? First, we're going to draw a picture of the situation, like we usually do. On the left here, we see I've identified ball A as the ball that is moving. It has a mass of 0.17 kilograms and is moving at 3.5 meters per second from left to right. It is striking ball B also with a mass of 0.17 kilograms that is not moving. The problem said that the ball that was moving moved 45 degrees to the right of its original direction. So since it was already moving to the right, it is now moving down and to the right at an angle of 45 degrees. The stationary ball moved 30 degrees to the left, so it is now moving 30 degrees up from that same direction. All of our two-dimensional momentum problems require us to fill out a table, as seen here. Now, our table for our previous problem only had 3 rows because the two objects collided and stuck together. This one has 4 rows because we have PA and PB before the collision. We also have PA prime and PB prime after the collision. Filling in our table, we can completely fill in the top half because we know mass and velocity for everything before the collision. Ball A had a mass of 0.17 kilograms and was moving at 3.5 meters per second. This comes out to be 0.595 kilograms times meters per second. Ball A was not moving in the y direction at all. It was simply moving to the right. Ball B is not moving at all in the x or y direction, which gives it momentum of 0 kilograms times meters per second in both the x and the y direction. After the collision, we actually do not have much information about either ball. We know that ball A is moving down at 45 degrees. We know that ball B is moving up at 30 degrees. Therefore, we take momentum PA prime and PB prime as it is a vector and split it into its x and y components. If you recall from Unit 2, when we did vectors, you could take a component and split it into its x component by using cosine and split it into its y component by using sine. So PA prime becomes PA prime cosine 45, x becomes PA prime cosine 45, and the y component becomes PA prime sine 45. There is a negative placed in front of the y component because A is going down in the y direction. PB prime gets PB prime cosine 30 for the x component and PB prime sine 30 for the y component. We now create 2 equations, one in the x direction and one in the y direction, from our table. Same thing as before. Momentum before the collision is equal to momentum after the collision. Before the collision in the x direction, we have 0.595 plus 0. So the left side of our equation is 0.595. The right side of our equation is PA prime cosine 45 and PB prime cosine 30. So our x direction equation is 0.595 equals PA prime cosine 45 plus PB prime cosine 30. In the y direction before the collision, we have no momentum. In the y direction after the collision, we have these 2 components right here, PB prime sine 30 and negative PA prime sine 45. So our y direction equation is that 0 is equal to PB prime sine 30 minus PA prime sine 45. To continue on solving this, we're going to take the y equation and solve for PA prime. Moving PA prime sine 45 to the other side, we now have that PA prime sine 45 is equal to PB prime sine 30, which would continue to isolate to be PA prime equal to sine 30 divided by sine 45 times PB prime. When we convert or use our calculator to find the sine of 30 and the sine of 45 and divide them, we find that PA prime is equal to 0.707-106-781186 PB prime. This is then substituted into the x equation. 0.595, and then we had PA prime. We'll go back and look at our x equation really quick. Here's our x equation. So 0.595, and then PA prime will be replaced with what we just solved for. So 0.595, 0.7071067811186 PB prime is what was PA prime. Cosine 45, which is 0.7071067811186 also, plus 0.8660254037784 PB prime. That's cosine 30. Adding all those things together, we get 0.595 equal to 0.5 PB prime plus 0.8660254037784 PB prime. Adding together the two terms on the right gives us 0.595 equal to 1.3660254037784 PB prime, and then solving for PB prime, 0.595 divided by 1.366 gives us that PB prime is equal to 0.435570230505. We can then substitute that into our PA prime equation that we had solved for right here. PA prime equals 0.7071067811186 times 0.435570230505. This means that PA prime is equal to 0.3079946636673. Now, if the question was asking for the momentum of each ball, we would be done. But it didn't. It asked for the velocity. Solving for velocity when you have momentum is simply a matter of taking the momentum and dividing by the mass. So for ball A, VA prime will be equal to PA prime divided by MA, which is 0.30799 divided by 0.17. This comes out to 1.811733157.2, which when rounded to two significant figures is 1.8 meters per second. VB prime is equal to the same thing, PB prime divided by MB. So this equals 0.435570230505 divided by 0.17, which is 2.562177, so on, which rounds to 2.6 meters per second. Make sure you email me when you have any questions.